Good morning friends. In this lecture I am going to discuss a new topic students. The topic name is nonlinear partial differential equation of first order. Let us see the concept students. Nonlinear partial differential equation of first order. What is it students? Nonlinear. What is linear students? What is linear? Linear means degree is 1 students. Degree is 1. Degree is 1 students. Non-linear. Non-linear means degree other than 1 students. It may be 2, 3 and so on. Okay. Non-linear partial differential equation of first order. What students? Order is 1 students. Order is 1. Okay. Please remember students. Degree is other than 1. That means more than 1 students. Let us see the definition students. A partial differential equation which involves first order. What students? It is first order. Please remember students. It is a first order. Partial derivatives. What students? Partial derivatives. What are the partial derivatives here? P and Q students. What are the partial derivatives? P and Q. What is P students? What is P? What is P? P is equal to dou z by dou x. And what is Q students? Dou z by dou y. P means dou z by dou x and Q means dou z by dou y. Dou z by dou y. What is order here students? What is order? Order is 1 students. Order is 1. Order is 1. Okay, with degree higher than 1 students. Degree higher than 1 students. Degree means here degree 1 students. That means I can take here, if I am taking p square, what is degree here students? 2. Dou z by dou x whole square. Okay students, higher than 1. It must be, or students, higher than 1. And the product of p and q. Okay students, higher than 1. It may be p square or product students. It may be product pq or p square q square, like the students. Is called nonlinear partial differential equation. It is called nonlinear partial differential equation. Once again students, a partial differential equation which involves first order students, first order partial derivatives p and q with what students? With degree higher than 1. Degree is higher than 1 students, but order is 1 students. Order is 1, degree is other than 1 or more than 1. And the product of p and q is called nonlinear partial differential equation. What students? Nonlinear partial differential equation. Now let us see the example students. Examples. What is say students? P square plus q square is equal to 1. See students, p square means dou z by dou x whole square. What is order? What is degree students? Degree is 2. So degree is 2 students. So this equation is called nonlinear partial differential equation. Okay students, nonlinear partial differential equation. And second one is students, it is p into q students. It is p into q. Okay, dou z by dou x into dou z by dou y. Okay, here also degree is 2. Now see here students, p square q square, again degree other than 1 students. Okay, now these three are examples of nonlinear partial differential equation. What students? Nonlinear partial differential equation. I want to find solution of such type of equation students. I want to find the solution of such type of equations. Is it possible students? For the nonlinear equation, sometimes it may be difficult students. So that there are some particular form students. Particular form is standard forms. What students? Standard form students. There are certain standard forms. For the certain standard forms, certain procedure students. Okay, to find the complete solution. Now, before going to the standard forms, what is complete integral or complete solution, or particular integral or particular solution, or singular integral or singular solution? Let us see the definition students. Complete integral. Complete integral, everybody knows, students. Number of arbitrary constants is equal to number of independent variables. Everyone knows. Let us see the definition, students. A solution in which the number of arbitrary constants is equal to the number of independent variables. Okay, students. How many independent variables are there, students? How many independent variables are there? 2 independent variables, students. How many independent variables, students? 2 independent variables. For the 2 independent variables, if we have 2 arbitrary constants, okay, students, in the solution, if there are 2 arbitrary constants, then the solution is called complete solution. What, students? Complete solution. If there are 3 independent variables, there are 3 arbitrary constants. If there are 1 independent variable, there is a 1 arbitrary constant. Then the solution is called complete solution. Complete solution means number of independent variables is equal to number of arbitrary constants. Number of arbitrary constants is equal to number of independent variables. Right. This is about complete integral, students. And then particular integral, students. Particular integral, if we give particular values to the arbitrary constants in the complete integral, it is called particular integral, students. Suppose a is equal to 1 and b is equal to 2. It is a particular integral or particular solution, students. But there is a difference, students, here in singular integral. This is very, very important, students. Singular integral. Singular integral. See, students, in the equation we have p, q, x, y, z, students. Okay, students, the equation contains p, q, x, y and z. He is right like this, students. I want to find singular integral here, students. Here the function contains here, that means the equation contains here x, y, z, p, q. Okay, whose complete integral is here. He finds complete integral, students. Okay, complete integral. Phi of, for this equation the solution is this one, students. Phi of x, y, z, a, b, that is equal to 0. Okay, students. Now you differentiate this complete integral with respect to the arbitrary constant, students. Or, students, differentiate complete integral with respect to arbitrary constants, students. Here arbitrary constants are a and b, students. Arbitrary constants are a and b. So that I am differentiating one partially with respect to a and b and then equate to 0. Okay, students. You differentiate this phi with respect to a and make it equal to 0. And again with respect to b is equal to 0. By using 1, 2, 3, if you are eliminating a and b, okay, students, then get to solution. The solution is called singular solution. Or, students, singular solution. Very, very important, students. Singular solution. Right. Once again, students, he given a equation. We are finding complete solution, student, by knowing method. By known methods, we are finding complete solution. Okay. After finding the solution, suppose if I have c and d here, I am differentiating partially with respect to c and d, students. If it is c1, c2, and differentiating partially with respect to c1 and c2, students. Depending on the problem, what you are taking the arbitrary constant depends on the arbitrary constant, students. Right? Please remember, students. Right. Now differentiating one partially with respect to a and b. Differentiate, students. By using these three, we are eliminating a and b, students. That means the solution doesn't contain a and b. Okay, then the solution is called singular integral or singular solution. Here integral means solution. What, students? Integral means solution. Now here we have standard forms, 4 types of standard forms. Actually there are 6 standard forms. It is enough to know these 4 standard forms, students. Okay, students, the first one is f of p comma q is equal to 0. Okay, students, you have to remember the standard forms. There is no other option, students. Please remember, there is no other option. You have to remember. Okay, you have to remember the standard form orders. The first form is, students, first standard form is f of p comma q that is equal to 0. That means here the equation contains only p and q, students. and is equal to 0. Okay, that is standard form 1 students. And standard form 2 is p comma q comma z students. What is extra term here? Z is equal to this. This is second standard form students. And third standard form contains f1 of x comma p, that is equal to f2 of y comma q. That means standard form 3 contains x, p, y, q. X, p, y, q. Okay students, z is equal, and fourth standard form is, this is standard form students. It is easy. What is first standard form 4? Px plus qy, that is equal to f of p comma q. This is standard students. Px plus qy, it is common for all the problem. Px plus qy is common students. Where this change occurs? At f of p comma q. It may be pq or p plus q, p square plus q square, etc. Okay students, where the change is? Here we have change students. Okay, these are the standard form students. These are the standard forms. Once again students, what is first one? P comma q, f of p comma q is equal to 0. What is second one? P comma q comma z is equal to 0. What is third one? f1 of xp, that is equal to f2 of yq. And what is fourth one students? Z is equal to px plus qy plus f of p comma q, f of p comma q. In sometimes what happens students, the p comma q are there are extra terms also there students, like xy. Okay students, in some cases all the terms contain students. Then we have to reduce in standard form 1 or 2 or 3, depending on the problem which is suitable standard form, we are reducing into students. Okay, please subscribe this channel students, like this video, and share as many as possible students. Hope you understand. Thank you for watching this video. Jai Hind.